Hello. Now, now I will be showing demo of a regression problem using pycaret on how I solved. So pycaret, as we know, is a low-code AutoML library. It has a different set of uh, libraries which can be used to automate ML workflows. So starting with the installation of pycaret, we use pip install pycaret full, uh, which installs all the complete pycaret packages and we have installed. Next, we can check the pycaret version we have installed. Pycaret dot underscore version underscore. We install the latest version. Now for the data, I used house price regression data for this regression problem from Kaggle. So the first step in pycaret is starting a session with the help of a setup function. So it the parameters it requires is the data, the target class variable we are predicting. So it returns some metrics as we can see about the data, and it also shows that the pre-process is done. So the next step, basically, pycaret has two sets of APIs. One is functional API and the other is object-oriented API. So here they have used object-oriented API. Basically, they create an object, import a class, and create an object, and so that all the methods and properties of the class can be obtained with the object, and we can perform various uh, functionalities using that object. So anything is the same. They created using the setup function. So we used the regression experiment variable and object variable to create a setup function. Everything is the same. So now coming to the training, we use a compare models function which trains all the available estimators based on the data we have uploaded. It gathers all the available estimators and trains them using cross-fold validation by taking the default folds as 10. And we can see the best performing model is here is linear regression. So also we can use other models as well by using the function create model. We can train the model we like, and we can see the accuracy metrics of cat boost model as well. The mean square error, root mean square, r square. You can see all the metrics here, accuracy metrics here. And coming to the visualizations, so for regression models, uh, you can use residual models. Basically, it compares the r square of trained versus r square of test. R square, basically we use it whether to check how well the model is fitted with the data. So we can check the plot here, and the same uh sorry, and the next plot is error plot, finding the error. The reason why I've chosen cat boot regressor model instead of linear regression is I've got some errors with some plots, as it doesn't, as some regression models doesn't support all types of plot attributes. So I had to I had to take another model. So I used catboost regression model for plotting, which almost supported various, which almost supported different plots. So we can see the feature importance plot as well, which feature has the most highest importance in determining the price of a house. Here, square footage is the biggest, most important variable that decides the price of a house. The rest of them are not that important. Size, lot size, year built, etc. Number of bedrooms, etc. And we can use evaluate model function to get the pipeline. You can see the data is passed, raw data is passed into simple imputer functions, and after conversion, it goes to catboot get boost regressor model. Now, as our model is done, created, uh, we can predict it using predict model function, which takes the model as input, and by default, the data set we have uploaded, it takes some of the data and trains and predicts the values. So by default, it creates two new columns called prediction label and prediction score. On the right hand side, we can see the prediction label versus the actual house price. So next, what we do is we delete, sorry, we copy the original data and remove the class variable, the target variable we are predicting. Even though if we remove the target variable, uh, the prediction is absolutely same. I mean, it can able to predict it can be able to predict even without the target variable as well. On the right hand side, we can see even without the target class house price, it predicted. So as the prediction is pretty good, uh, we can save the model using the save model function and load the model transformation pipeline using load model function. So this shows the transformation pipeline of how our data goes into cat boost regressor, starting from basic transformations and by simple imputer, and then it goes into cat boost regressor. And the next is using gradio. uh, Gradio is used to design an interface for our model and create an endpoint so that it can be accessed from anywhere. uh, the demo of Gradio I will show in the next video. So thank you.